Next, we're going to look at buses. We typically have address buses and data buses. Think of these buses as a major highway, an expressway, that is used to commute instructions and data within the computer system itself. These are used for input and output and to identify areas of memory to either read from or write to. That would be an address bus. And then we have the data bus. Now that I'm latched into this one location in memory, let's flow the information from that memory location in RAM to the cache memory and or buffer memory so that the CPU can work upon it. Here we see an example of the system buses to the right. We have the address buses and the data buses. Again, the wider these are, the more information we can flow with each clock cycle. These address buses and data buses, again, commute instructions to memory and then read data to and from memory so that the CPU can perform the work on that particular piece of information. On the left, we see the processor with the control unit, the ALU and CPU, and then of course we see the clocking. The whole system runs on a clock, so there is a single clock pulse that all components in the system can see, and this way they can remain synchronized with the other components. A 32-bit architecture versus a 64-bit architecture. In the last couple of years, the 64-bit architecture has grown. What are we talking about? We're talking about the width of the address buses and the data buses on the motherboards of the computer systems themselves. The more lanes we have for these data bits, the more information we can commute in a single clock cycle. So if I needed to commute the same amount of data on a 32-bit bus versus a 64-bit bus, it will take twice as many clock cycles to get that data clocked through, because the 64-bit bus has 32 more data bits per clock cycle. Here we see that all components, again, are controlled / managed by the central processing unit. And again, they are all synchronized with that clock signal that we saw earlier. And again, the clock signal that we're talking about is generally the 2.4 gigahertz, the 3.6 gigahertz CPU clock that we see referred to when we go to purchase that computer system.